All right. Welcome, everyone. So, to get started in our first lesson, I'm going to show you exactly how you can predict, with a very simple model, by the way, predict Bitcoin EMA using LightGBM. Okay, this is going to be very straightforward, but also very fun. So, essentially, we want to know how can we forecast what the Bitcoin EMA is going to do. And to do that, we need essentially, now, first of all, I'm using the cursor ID. You can use VS Code. Both are totally fine. Just make sure that you have Jupyter installed, the extensions and Python. So first things first is we're going to install some dependencies. So install yfinance does NumPy, LightGBM, matplotlib, of course, because we want to see what we have forecasted. scikit-learn, and we had upgrade. Yeah, that would be quite nice. And let's run that. I think I have them installed, so let me just double check this. Okay. Yeah, great. Perfect. We can clear this output. It's quite messy. Second is we will do some imports. So we got import yfinance as yf. Perfect. Pan SPDs, NumPy SPD. Yeah, these are great for auto completion. Perfect. I'll just adjust the sklearn import. So model selection as model selection, or actually let's do string test split from sklearn dot metrics import mean. Okay, lovely. Mean squared error we'll be using to essentially measure our performance. Simple as that. And next we will do from LightGBM import early stopping and log evaluation. All right, that's pretty much it for the imports. Let's get that going. Let me just kill some of the space here. All right. Now, next thing is we want to download the data. And we can do that through YF, Yahoo Finance. Let's see, download, that should be fine. Yeah, 2015. Yeah, let's just do 2016. That's perfect. And we do BTC equals BTC close. We only want the closing price for now. We don't want to look at all the other. So any open, high, low, close, etc. We don't need that for now. And then we will do BTC.drop in place true. So essentially what we're doing is we're looking and saying, look, drop any null entries in the columns and do that for this data frame right here. Just for an example, you can also just print the head of the data set. Because we're using Jupyter, we don't have to actually signify print. So I'll show you, if it wasn't a normal Python script, you'd do the following, but because we're using Jupyter, we don't actually have to do that. And we'll run that. It will download the data. And here you go. This is what the data starts like on the 1st of January 2016. Great. Next, let's calculate the EMA. This is really easy to do. Actually, Pandas has a built-in method for that. Perfect. So BTC EMA, close, span 20. Yeah, we can do that. Let's change that maybe to 10. And let's actually name this to 10 so we can identify it. And that will do for now. And then we can also create some lag features. So with LightGBM, every column is looked at, or every row is looked at separately from the previous row. So there is no, oh, look 5 steps back and infer based on that. No, it looks only per step. So we're going to create lag features to mimic each row essentially having previous row information. So for that, we can just do for I in range 1 to 6. You can, again, make this 20, whatever, it's all fine. And we will exactly accept this code. That's exactly what we want to do. Lag, and then shift multiple times, so up to 5, 1, 2, 3, 4, 5. And again, drop any null or unavailable rows. Perfect. And now we will define the features. So let's see, define the features and target. Yes, yes. Let's see. I will prefer to start like this. As lag I. Oopsie. Let me just get that in here. I in range 1, 6. That's it. Keep it simple and keep this on another line. So X is BGC feature. So X essentially is the train set. So this is the data that the model will be training on. And it will have access to all the features. And then Y will be only the target, essentially. So EMA 10 is the target that we're predicting, so we'll only have access to that type of data. Validate. So now let's do X train X. So we're just going to do a split without any shuffling. So X train, X test, Y train, Y test, changes. That's perfect. So that's exactly what we want. I think what I will do is say shuffle equals false. Let's keep it at that, to be honest. Great. We have an error. Let's say train test split X Y shuffle equals false. I'll come back to this issue in a moment. I think this would be easy to solve. And then, wait, it could be, hold on. So X train, X test, Y train, Y test is train test split. No. Oh, right. My import is incorrect. Right. So we will do from sklearn model selection import train test split. There we go. So we run that again. We will essentially have to rerun everything. So we'll just do that, restart, and then run all. And I'll go through all the selection here. We'll just give it a minute and wait. We got the data, everything's correct, lovely. Okay, now we're going to just define LightGBM with param. So model equals LGB dot LGB regressor, great. An estimator, learning rate, number of leaps, max depth. I'll go with this. I think we will just cover these hyperparam for now, nothing else. Just as a starter, I don't want to overcomplicate this for anyone. And we'll do model.fit. And I will explain these in the coming videos more in depth, but for now, I don't think we need to cover this directly, just to get a working example, essentially. This is a great suggestion. So log evaluation period 100. You can also set it to 50. Stopping rounds, lift all those for 50. I mean, that much. Let's use RMSE. And eval set eval name, we can get rid of the eval. Sometimes with cursor, you have to be very, there we go. Okay, now we can essentially run this cell. Ah, right. Yes. Let me go back. Yeah. So essentially, when you do YF download, it downloads a multi-index, and we don't want that. I can demonstrate that by doing btc.tail. Actually, no, dot columns, just to show you. You see multi-index. That doesn't work for us, right? So we need one index. And to fix that, we essentially, let's see, it was yf.ticker, like that. And we pass, let me just cut these out. We'll need these in a second. Okay. So YF ticker BTC USD, then we do dot history, and then we paste in what we just had before. Okay, that should fix our issue here. So let's clear everything, restart. I guess I can just comment out this part here. We don't need the installation, and run all. Simple as. There we go. There we go. Okay, we will talk about the RMSE in a moment. I'll just plot everything for a second just to show you. So let's do the prediction here. So predictions equals model.predict x test num iterations model.test iteration. And we do RMSE equals np.root. Perfect. Thank you for that. We can also log. Let's remove the plotting for here. And that. So this is what we get. Nearly there. And let's visualize this. So let's do plt.figure fix size. Yeah. Next is plt.plot y test index y test, and then label equals actual EMA 10. We can do line width 2. Right, perfect. And then let's add some labels. I want this to look pretty. So plt.x label date, y label EMA 10. We could just add BTC EMA 10. And then we do legend, and then plt.grid. And then we'll do plt.light and light layout, and then show this one, that. Lovely, lovely, lovely. Okay, so the actual EMA 10, as you can see, is shown in blue here from 2020 to end of 2020. And the predicted EMA is in orange, and it's showing that it's going near like the price, but not completely. Again, we did not do any hyperparameter tuning. We didn't add too many extravagant features, and we're only looking at the close price. So this is a very, very minimal setup, but we still managed to get some interesting data. Now, what does this value mean? Our model is predicting with RMSE 1,478. This means that for each prediction, we are essentially off, give or take, $1,478. Okay, so if Bitcoin price is ranging to 2,500, or let's say the last point here before it flattens is $16,000, our predictions are off by $1,400. So it could be above or below, essentially. So it's not that accurate, but this will do very well as a base to understand how we can build something that can consume data, learn from it, and try to predict. Again, we're using regression, not classification here, and we will look at other methods in the following video. So this is just a starter for you to understand how to do this. I hope this was helpful, and I'll see you in the next video.